Good day, guys. My name is Tawam Shapo. So today I'll be introducing you kinematics in one dimension. Our topic for today is kinematics in one dimension. So when we are talking about kinematics, it is whereby we are focusing on how the object moves and the force that influences the object. So this topic is very broad. So we are going to start by defining the concepts that we have. The first concept we are going to define are vectors. We've got vector quantities. Maybe you're asking yourself, what are vector quantities? So vector quantities are quantities that has both magnitude, which is your size, and direction. So maybe you are asking yourself, vector quantities are quantities that has both magnitude and direction. So let me give you examples of those examples. The first example can be the displacement, because the displacement consists of the magnitude, which is your size, and the direction, displacement, whereby we focus on where the object is from the reference point. For instance, let me make a scenario so that you can understand what displacement is. So there's this boy who's moving to the right, and he moved for 20 meters. Then this boy noticed, no man, I left something at home. Then this boy goes back for 15 meters. So then the question is going to say how far the boy is from his home. Then what you are simply going to do, you are going to choose your direction. Maybe we are going to say left, right, be positive. Then after we have chosen our direction, we just solve for the displacement. We are going to say delta x is equal to all the distances that the boy traveled. So we are going to say is equal to 20 meters plus, since our direction is, we took right as positive, which means everything that is going to the left is going to be negative, which means it's negative 15 meters to the left. Then the displacement of the boy is 5 meters to the right. That's how you find your displacement. It's whereby you look at where the boy ended, because he started by traveling 20 meters to the right, then he went back home and he walked for 15 meters. So the question said, what was the boy displacement? How far the boy is away from home? Then you use this procedure. Then another vector quantity, let me erase this. I think maybe you are covered with what I was trying to illustrate. Then now I have to erase and we move to the next vector quantity. You have to keep in mind that vector quantity consists of both the magnitude, which is your size, and the direction. Then another example we can say is after displacement we can say velocity. How can you define velocity? Velocity can be defined as the rate of change in displacement. And so whereby when we talk about the rates, it's whereby you focus on the time that it takes an object to cover a certain distance. So the formula to get velocity is v is equal to delta x over delta t. This is the formula to get the velocity, which is the rate of change in velocity. And the SI unit for velocity, they are meters per second. And you also choose your direction. You choose your direction, then everything will be sorted, will be covered. Then let me make a scenario for you to show that velocity is also a vector quantity. Let's say maybe they are telling us that the ball travels for 10 meters east and it took 5 seconds. Then your question will say maybe calculate the velocity. Calculate the velocity of that ball. So the first thing you need to do is that you choose your direction. So since we are given one direction, we are given east, we are going to say let east be positive. Then we know that to get our velocity is equal to the rate of change in displacement. Then we just substitute. We were given how many seconds? Let's see. We were given 5 seconds and 10 meters. So we are going to substitute that on our formula. Then we are going to say 10 over, how many seconds were we given? Let me go back, sorry for that. We were given 5 seconds. Then we are given 5 seconds. Then our velocity is going to be v. Our velocity is going to be 2 meters per second east. You see, so velocity is considered a vector quantity because it consists of the magnitude, which is 2, and the direction, which is east. Then I move to another example. I think we are covered. Or maybe I'm moving too fast, but I'll try to break them down for you. Then we go back to, let me erase everything so that we'll have enough space. So that we'll have enough space to do more problems. These questions are very interesting. Now I'm just making them simple so that you'll be able to understand the concepts. Then let's move to another example. Another example that you can use. Another vector quantity we are going to talk about is the acceleration. So now we are going to talk about acceleration. What is acceleration? Maybe you're asking yourself. So acceleration is the rate of change in velocity. So the formula to get acceleration is A is equal to change in v over change in time. That's our formula to get the acceleration. So maybe let's say we are given the velocity of 7. They are telling us that the car moves from rest with a speed of, with a velocity of 14 meters per second, and it took the car 2 seconds. So now we are required to calculate the acceleration. We are given that the velocity is 14 and the time is 2. Then the car is moving to which direction? Let's say the car is moving to the right. Then we are going to get 7 meters per second squared, then to the right. So we call acceleration a vector quantity. The reason behind that is that it has both the magnitude and the direction. I think that's enough for now. Then we move to our last example of the vector quantity, which is